We're going to look at a hypothesis. And today I want to look at even two hypotheses. But first, what is a hypothesis? A hypothesis is a claim about a population parameter. Another word for a hypothesis is a claim about a population parameter. To hypothesize is to conjecture, predict, project, and all sorts of things. So when you are doing hypothesis testing, there are 4 steps you have to note. There are 4 steps. Please write them down. The first step is formulate the null and the alternative hypothesis. That is a step 1. Formulate the null and alternative hypothesis. So what is a null hypothesis? The null hypothesis is the authority statement. The authority statement. It comes from the one with the authority, the null hypothesis. The alternative hypothesis is a mirror image of the null hypothesis. The alternative is a mirror image. The null hypothesis is represented by H naught. Please write it down. The null hypothesis is represented by H naught. Who can tell me what the alternative hypothesis is represented by? Who can tell me? The alternative hypothesis is represented by what?
Doc, I'll assume H1.
H1. Sometimes we use HA. HA. Other times it's H1. So both of them are good. The null hypothesis, H naught. The alternative hypothesis, HA or H1. Now let me ask you a question. Suppose I say that the 2026 EMBA cohort will all get A. And then, so I make that statement. And then Kathy Saki also makes a statement. And Kathy says, the 2026 EMBA cohort will get A in research methods. Which of these 2 statements will shake the student? The one made by Kathy or the one made by myself? Which one?
The one made by you, Prof.
The one made by me. Please always raise your hand. They will help me to call on the right person. So why would the one made by me shake the class than the one made by Kathy? You can tell us. Ibrahim.
Yeah, Prof, because you are the one with authority.
Exactly. That statement, is it a null hypothesis or the alternative? The statement I made, is it a null or the alternative? Steve, Sven.
Yes, please. The statement you made is the null hypothesis.
It is the null hypothesis. Now, write this down. The null hypothesis always has some level of equality in it. The null hypothesis always has some level of equality in it. Now, let me explain what that means. There are 6 major symbols that we use in detecting the gravity of something. The first symbol is not equal to. What is the opposite of not equal to? You can tell me. What is the opposite? Richmond.
Equal to.
Good. The opposite of not equal to is equal to. Another symbol is less than. What is the opposite of less than? You can tell us. Emanuela.
This is greater than.
That is wrong. Priscilla. Just say that you are going to say the same thing.
The same thing, yes.
That is wrong. Uriel.
Greater than or equal to.
Exactly. It will be greater than or equal to. And then, what would be the opposite of less than, greater than? What is the opposite of greater than? With the power line, can be. What is the opposite of greater than? Esna.
Greater than or equal to.
Debbie. That's not correct. Yakin dampo.
Less than or equal to.
Less than or equal to. You know, I normally say in class that sit beside the right person. And I whom you sit with matter more than whom you don't sit with. Now, since we are now on Zoom, I will say that whom you listen to and write down is important. When I say opposite, opposite is something that goes in an opposite direction. So, for example, if you say that she is less than 30, the opposite cannot be she's greater than 30. Mathematically speaking, that will be wrong. Because if you do that, you will not know where you will put the 30 on the number line. So the opposite of she is less than 30 is rather going to be she is 30 or more. Do you agree with that? She is less than 30. Its opposite is supposed to be she is 30 or greater than 30. So that 30 will also be part of the number line. If you don't understand, you raise your hand, I explain it further. If you don't understand, you raise your hand, because this is the foundation that you should understand before we proceed. The same way, opposite of greater than is less than or equal to. So the first step in hypothesis testing is to formulate the null and the alternative hypothesis. That is the first step. The second step in hypothesis testing is to find the test statistic and the critical value. Find the test statistic and the critical value. Now, the third step, I told you there are only 4 steps. The third step is to find alpha and the p-value and compare. Find alpha and the p-value and compare. And the last step, step number 4, is to decide and conclude statistically and practically. Decide and conclude statistically and practically. We're going to go through all of these steps right now on 2 situations. So, let's start with step 1 again. Formulate the null and the alternative hypothesis.
Yes, Prof. Please, you mentioned that there are 6 major symbols for that hold some gravity for what we are going to do. And I think you mentioned 3. Or is it 3 times 2? Because they were the opposites.
Exactly. They are the
Okay,
opposite.
thank you. Okay, thank you.
Very
Thank
good.
you.
So the first step is to formulate the null and alternative hypothesis. How do you do that? Well, you do that formulation depending on the sample. Pay attention. You do that formulation of the null and alternative hypothesis depending on the what? The sample. And by the way, I want you to know these symbols, you are in a note, so please check them. Depending on the sample. If the sample is one sample, the way you will formulate the null and alternative hypothesis will be different from if the sample is 2 samples. And that would also be different from if the sample is 3 or more samples. But I want you to check the symbols here. You see the symbol? Yes, patience.
Prof, please, I'm sorry. I didn't get what you said. Like
Okay.
with the symbol here.
With a symbol or with what I just said?
No, when you got here, I think I lost you. So I didn't get what you said.
Okay, so what I was saying is that we are looking at the first step in hypothesis testing. And that first step is to formulate the null and the alternative hypothesis. You remember that one? Then I said that in order to formulate the null and alternative hypothesis, you need to know the sample you are dealing with. Now, whatever I'm saying right now is not on your screen yet. You need to know the sample. Now, if the sample is one sample, it's something like this. Suppose I decide to record the ages of everyone in this class, irrespective of whether the person is a male or a female. So I record the ages 28, 35, 42, 55, 60, 41, and then on and on and on. This sample that you are seeing here, it is a one sample because it's just looking at ages of students in a class. Okay, that's one sample. But suppose I now have another sample, which is the ages of women in the class and then ages of men in the class. And then while this is 20, this is 41, this is 22, this is 22, this is 15, this is that, and I keep having that. In this context, how many samples am I dealing with? How many samples?
3.
Forget about this, so we finish this one. Frederick.
Prof, 2.
2 samples. Now, suppose I do a test of students in regular MBA, weekend MBA, and then executive MBA. All of them, I do a test on research methods. And then I start recording the marks for each student in each of these MBA class. How many samples am I dealing with here? In this case, how many are the samples? Janet.
3 samples.
Janet.
Please, 3.
Okay. So we're talking about 3 samples here. So what I'm saying is that the kind of sample that you are dealing with will determine the kind of null and alternative hypothesis formulation you will make. That's what I was saying. Do you understand so far? If you don't understand, say. Do you understand what I'm saying?
Understood.
Okay.
Yes, please.
Now, to do the hypothesis formulation, You need to know the English symbols. So on your screen, there are symbols for less than, there are symbols for greater than, English words. For example, when an English person says the word below, what symbol come into your mind? Which of these symbols come into your mind? Who can tell us? Below. What symbol come into your mind? Laurie.
Less than.
Less than. I agree with you. When the person also says beyond, what symbol comes into your mind? Beyond. Just make sure say and then what can be what can say be buy and be when okay be. Yes, Felicia.
Greater than.
Greater than. Now, when the person says not fewer than, what symbol is that? Be careful here. This is tricky. Frederick.
Well, is it greater than or equal to?
It is greater than or equal to. Correct. When the person says not above, what symbol is that? Wisdom. Not above. Felicia.
Less or equal to.
Less than or equal to. Very good. When the person says better than, what symbol is better than? Be careful. Better than. What symbol is that, Felicia? Felicia.
Sorry,
What?
sir, I was.
Greater than.
Greater than. What symbol is at least? At least. Georgina.
Less than.
No. At least.
Less
Wisdom.
than or.
Georgina, you have only one choice in my class. You remember the
Okay,
test we
sir.
did? You drink
Yes.
deep or you taste not. Yes, let's go to wisdom.
Less than or equal to.
That is wrong. At least. Esinam.
Greater than or equal to.
Greater than or equal. I hope you didn't guess.
No, sir.
Because sometimes the way the answers are going, if you don't take it, you do elimination by rough tactics. What symbol is at most? See, if you don't know, you should be writing things down. At most. Leonard. Leonard.
Less than or equal to.
Less or equal to. What symbol is not at least? Not at least. You have to always opposite the at least. Pamela.
Prof, that's less than or equal to.
That is not correct. Not at least. What symbol is that? Felicia.
Greater than or equal to.
Greater than or equal to is wrong. What symbol is not at least? Wakasa, you Janet. Yeah, Janet, your hand is up. All right. Mahina Boat.
Greater than.
Greater than. That's wrong. So not at least is less than. At least is greater or equal to. Its opposite is the not. Its opposite is the not. So not at least is the opposite of at least. And since we already know that at least is greater or equal to, not at least will be less than. Now, there are some English words that will also signify, yes.
Prof, if you say opposites, if the opposite Shouldn't the opposite of greater than or equal to not be less than or equal to?
No, we just corrected that. I don't know whether you just done a class. Some few minutes ago, we said that opposite of less than is never greater than. You remember?
Okay. Yes.
Opposite of less than is greater or equal to. Write it down. You didn't write it. That's why you're struggling again. You know. But if you had written it, you would not have struggled with that. The best way of learning is writing. Now, there are some indicators of two-tail. One of them is not equal to. Another word for not different from. What symbol is that? Not different from. What symbol is that? Leonard. Leonard.
Yeah, not equal to.
Not different from. No, that's wrong. Priscilla.
Equal to, sorry.
You know, you don't have to say sorry. I mean, you already have the microphone now. That's why you could even say, hey, you got to think before. So in my world, you have failed. Yeah. What symbol is differs from? You have only one chance. So think before you raise the hand. Differs from. What symbol is that? Priscilla.
Not equal to.
Not equal to. Correct. The same as. What symbol is that? The same as. Kathy.
Equal to.
Equal to. Does not vary from. What symbol is that? Does not vary from. Priscilla.
Equal to.
Equal to. On. What symbol is that? On. A baby or hapa. On. What symbol is that? What thing?
Greater than.
Equal to. Greater than pa. Maybe I'm correct to say. Or commodore. Off. What symbol is that? Off. What symbol is that? Was. What symbol is that? So all of them are equal to. Take note. If you didn't know, now you know. So no problem. The most important thing in learning is that now you know. So we are going to look at two sample hypotheses. And to do that, I'm going to show you a certain table. And I'll spend quite some time on the table. So please pay attention. Okay. I'm jumping one sample and I'm going to go to two samples. But I want to show you something about the table first. Easy, I don't want to clump you with so many things. So look at the table on your screen very carefully. I will ask a series of questions on this in the exam, so pay attention. Do you remember the second step in hypothesis testing? Who can remind us of the second step in hypothesis testing? Second step. Who can remind us? Yeah?
To find a text, statistics, and critical value.
Good. The kind of test statistic you're going to find will depend on the distribution of the data. It will depend on the distribution of the data. The data can be normally distributed, and that is sometimes called parametric. Or the data can be not normally distributed, and it's sometimes called non-parametric. If the data is a parametric sample or is distributed parametrically, the way and the test statistic you will use is different from if the sample is non-parametrically designed. This point I just wrote. I just said it's very important for you to write down, put in your own words. The table on your screen indicates the test needed for undertaking parametric tests. The table tells you the steps needed to take a hypothesis testing, depending on whether the data is normally distributed, parametric, or is not normally distributed, non-parametric. Each one has got its parametric version and its non-parametric version. So let's start with the first one. What is the parametric version for a dependent t-test? Now, what is a dependent sample? You remember I gave you the sample ages of women in the class, okay? Ages of women. Then I also gave you ages of men. Now, ages of men and ages of women, the sample is independent. Independent. Why? Because the subject, the people who are women in this class are different from the subject of men in this class. So the sample itself is 2. So when you record the ages, and the ages are 29 here, 30 here, 33 here, 40 here, and so forth. The samples are 2, but the people, the subject, are also different. And when the subject is different, it is said to be dependent sample. Take note. Take note. Dependent sample is the one where the subject is different. Now, independent sample is when the subject is different. Take note. Dependent sample is when the subject is the same. So let me give you another example. When the subject is the same. So let's say that I record the marks of 7 people, okay? 7 people in this class. So the first is Kofi. You have Afi. You have Ama. You have Ya. And then you decide to look at their scores in research methods. Their scores in quantitative methods. Okay? And then Kofi had 50% in research methods, 90% in quanti. Afi had 72, and then 78, and then it goes on and on. Now, if you look at the research methods and the quanti, these are 2 separate samples. But the subject is how many? Who can tell us? The subject is how many? How many are the subject? Leonard?
2.
Explain. Oh, did you say the subject is 2?
Yes, please.
That is incorrect. Marion? Marion?
The subject is 4.
Hey! Adrian, where do you? Richmond?
Prof, I think the subject is 1.
Explain to them.
So the subject, so for the first one is Kofi. So it's the same Kofi who is getting, who is having the marks 50 and 90.
Those of you who said 4, do you understand? The subject is the person whose information you are recording. That's the subject. The subject is the person whose information you are recording. That's the subject. And the sample here is 2. But then each observation has recorded 2 separate samples. Do you realize that? This is known as dependent sample. Dependent sample because the subject is the same person. Is the same person. So when I ask you in an exam, we'll differentiate between dependent and independent sample. You can undo it. You can understand it. You can do it. It's very important. Okay. Now, when the sample is dependent and the data is non-parametric or is not normally distributed, then we are here. Okay. If the data is not normally distributed, that means that it's non-parametric. And in that case, if the sample is dependent, the test statistic you're going to use is called Wilcoxon signed rank test. Wilcoxon signed rank test. But if the data is normally distributed, then you use a paired t-test. Paired t-test. That is if the sample is still dependent. If the sample is still dependent. But what if the sample is not dependent? What if the sample is independent of each other? Well, in that case, if the data is normally distributed, you use the paired. Okay. Sorry. If the data is normally distributed, you use the independent t-test. Sometimes it's called a Welsh test. Independent t-test, also called a Welsh test. But its non-parametric version, that is if the data is not normally distributed, is known as the Mann-Whitney U-test. Mann-Whitney U-test. Or sometimes it's called the Wilcoxon signed rank sum test. Wilcoxon rank sum test. Okay, all of these are if we have two samples. What if we have 3 or more samples? Well, if you have 3 or more samples, all you got to do is to check whether the samples are dependent or independent. If they are independent and the data is normal, we use analysis of variance. Otherwise, we use repeated ANOVA. Okay, we use ANOVA, independent ANOVA, or repeated ANOVA, which is also called dependent ANOVA. But if the data is not normally distributed, you use a Kruskal-Wallis test or you use a Friedman test. So anything on the left is non-parametric equivalent is what is on the right. Ladies and gentlemen, we want to look at Mann-Whitney U-test today. And then we'll learn all the steps in hypothesis test. So follow along with me. And when you don't get it, you get it. So let's start non-parametric Mann-Whitney U-test. Pay attention to what I'm about to say now. Mann-Whitney U-test is used when the data is not normally distributed. That's the first point. When the data is not normally distributed. And the sample is 2. And the subject are separate. They are also different. So we are dealing with 2 samples. Now, what it does is that it tries to check whether there is a statistically significant difference between the median of the 2 samples. Not the mean, but the median. So it uses a symbol known as M to represent the median. But because the samples are 2, it will have M1, which is the median for the first group, and then M2, which is the median for the second group. Remember, Mann-Whitney U-test, and it's also called Wilcoxon rank sum test. Wilcoxon rank sum test. I mean, the best thing you can be doing is to be writing a lot. Okay. So how do you execute it? Let's go to steps in hypothesis testing. The first step in hypothesis testing is to formulate the null and the alternative hypothesis. So we're going to take a storyline and try to understand. I'll guide you in the process. Okay. Now, The null and the alternative hypothesis. I told you that the null hypothesis always carries some level of equality in it. Write it down. And I know you've written it down already. Okay. The null hypothesis always has some level of equality in it. So when you take this one here, this symbol here is equal to, and you have the median of the first group minus the median of the second group. And this one is saying that the difference between the median of the first group and the median of the second group, the difference is 0. That word is 0 means is equal to 0. And because of the equality symbol, this becomes the null hypothesis. Remember, the alternative hypothesis always has no level of equality in it. But the null always has some level of equality in it. Okay. If you don't understand, ask. Now, you see here, I'm using equal to and its opposite, which is not equal to. But suppose the sentence was, if the median of the first sample is greater than the median of the second sample, then what you're going to have here is you're going to have greater than, and then its opposite. What is the opposite of greater than? What is the opposite of greater than? Greater than, opposite.
Less than or equal to.
Less, Priscilla.
Patience.
Less than.
Less than or equal to. That is it. So you know that one of them is going to be the null hypothesis. One is having greater than, the other is having less than or equal to. Which one will contain the null hypothesis? This is a beautiful thing. It's one of the symbols. Which one will have the null hypothesis? Loretta.
The less than or equal to.
Correct. The less than or equal to, because we have already indicated that the null hypothesis always has some level of equality in it. Very good. So I'm going to be giving you some preamble. Then you are going to tell me how to formulate the null and how to formulate the alternative hypothesis. Okay. Now remember, the way you do it is that you always have to step out and then write the null. You see the way this one is? The null, the alternative. Now this alternative that you've seen here is because of the symbol. That is why it is the alternative. Okay, let's take a couple of examples. Then you tell me which is a null, which is how do you write a null, how do you write alternative hypothesis? So example 1. This one is already telling you the null and alternative. The efficiency do not differ between foreign and domestic banks. Then the alternative says that foreign banks have higher efficiency score than domestic banks. There is a problem with the null and the alternative hypothesis. Who can tell me exactly? You got to be incredibly smart to tell me the difference between the null and alternative hypothesis. Class rep, get ready for the marks for this person for me. What is a problem between the null and alternative hypothesis, the way they have been written in English? There is a problem. Who can tell me for 2 months? One of them shouldn't be the way it is because of the way one is. What should have been the null, or what should have been the alternative? If you can tell me, I'm telling you, if you can tell me, it means you are great to start this whole module. Yes, I see it.
For the now, efficiency do not differ between foreign and domestic banks. But we know that the null hypothesis should have some element of equal to in it. So it should be efficiency is the same between foreign and domestic banks. So there's a problem with the first one. There should be some construction that equates efficiency to domestic banks.
So what should have been the first one? What should have been the second one?
So
Yes, sir.
So we can say efficiency do not differ from foreign banks to domestic banks. That's for the first one.
Mm-hmm. How do you
And then
alter that same first one? That's my question.
So I'm now using, okay, I can use is equal to, or I can use do not vary. So efficiency do not vary. Efficiency of foreign banks do not vary from domestic banks.
Say
I'm
that
not
again.
getting it right. Efficiency of domestic banks.
Which one are you
do not
formulating? The
vary.
null or alternative?
The now.
Mhm.
Efficiency of foreign banks do not vary from efficiency of domestic banks.
And then the
That's the
alternative?
now. The alternative is foreign banks do vary from domestic banks.
Excellent. To be honest, that is excellent. That is good. Excellent. I mean, that's perfect. That's too much. I know you've analyzed it. You have delayed in analyzing it so that you can get it also correct. You know, in the process of analysis, you were correcting yourself, Abby. And the thing, afa, it just say, oh yeah, afa. You have made them put their hands down. They were hoping that you were wrong, but the devil is a liar. That is good. So the first one, efficiency do not differ between foreign and domestic banks. That is a null hypothesis. The alternative ordinarily should be efficiency differ between foreign and domestic banks. That's it. Then that's it. But this first one, this alternative, is saying that foreign banks have a higher efficiency than domestic banks. This statement, have a higher efficiency than domestic banks, its null hypothesis should rather have been what? Who can guess that? Its null hypothesis should rather have been what? Uriel.
That foreign banks have efficiency scores less than or equal to domestic banks.
You think in normal English people will be using words like that? You have the idea, but you are using too much mathematics or statistics in your voice, which makes it difficult for anybody to technically understand. Loretta.
Yes, Prof. There's no difference between the efficiency of foreign banks and domestic banks.
No, you couldn't have said it that way. Given the alternative down there, the way you would have written the null shouldn't have been that. Kathy.
Foreign banks have lower or the same efficiency score than domestic banks.
I know, but yours is similar to the first lady. You know, lower or the same. Yeah, I know you are forcing the thing. Oh, forcing a show. Oh, forcing. Richmond, come and say some.
Oh, Prof, I would have said foreign and domestic banks have similar.
No. You can't go there. No. That one is unexpected. Frederick, Anna.
Prof, sorry, I think I was. So foreign banks have efficiency scores less than or equal to domestic banks.
Somebody has said it. So you could have simply said foreign banks have at most the efficiency of domestic banks. That's how you have written it. Foreign banks have at most the efficiency of domestic banks. Do you know that the at most here is the same as less than or equal to, which is what most of you are trying to say? Do you know that? Yes. So that is how ordinarily it would have been. Nobody got that part. Let's go to this one. If you were to write the null hypothesis and the alternative hypothesis for this sentence, mathematically, using the symbol M1, M2, and then indicating which is the null and alternative, how would you have written it? The median class size for maths is larger than the median class size for English. What are you going to write as the null and the alternative hypothesis? Yes, you can tell us. What is a null and what is alternative? Yes, Uriel.
Okay, so the null hypothesis will be M1 is less than or equal to M2, and the alternative will be M1 is greater than M2.
Very good. Did you guys get it? Say that again, say that again, say that again, say that again. You can't go scot-free like that.
The null will be M1 is less than or equal to M2. And the alternative will be M1 is greater than M2.
Okay, so in this case, which one is your M1?
Math, the median for math.
Very good, excellent, 2 marks. I hope you didn't copy because I know you can copy. Are you sure you didn't copy from anywhere?
No, please, I didn't copy.
Let's be honest. Are you sure? Because I know you have the book. Are you sure?
I'm very sure.
Okay. Class rep, that is the second mark for today. That is the mark for today. Take note. Okay. So the way she said it is something like this. Okay. That is similar to the way she put it. But I like it. That's 2 marks. Class rep, are you taking notes?
Yes, Doc, I'm here.
Very good. So today we have some 2 creme de la cremes here. Let's see whether there's more. Next one. The median class size for maths is not at least that of the median class size for English. How would you have written the null and the alternative hypothesis? Quickly, quickly, quickly. How would you write the null and the alternative? Now she has opened the eyes. Who can tell us the null and the alternative hypothesis? Yeah. Who is ready? Who is ready? Who is ready? Who will write the null and alternative hypothesis for this? Yes, send the name. Send the name.
Okay, so Prof, please, the null hypothesis, M1 is greater than or equal to M2. And for the alternative hypothesis, M1 is less than M2.
Say it again.
For the null hypothesis, M1 is greater than or equal to M2. And for the alternative hypothesis, M1 is less than M2.
Excellent. 2 marks. Very good. Very good. Set the noun. Cliche. You are shaking the foundations of the elements. Fantastic. So now, guys, we are going to take a sample, a real life exam question, a real life scenario, and then we analyze it non-parametrically. So please, get ready for the first 10 questions here. You're going to take a storyline. Somebody is going to read a storyline. Who will read it for us? And please, when you are reading, read it slowly so that others can be cogitating whilst you are talking. Who will do the reading of the Kolebu Teaching Hospital project for us? Yeah, who will do it? Okay, Marion.
Okay. Kolebu Hospital is undertaking a clinical trial designed to investigate the effectiveness of a new drug to reduce symptoms of asthma in children. Participants are asked to record the number of episodes of shortness of breath, dyspnea, over a 1-week period following receipt of the assigned treatment. The non-normally distributed data are shown below. Is there a difference in the number of episodes of shortness of breath over the 1-week period in participants receiving the new drug as compared to those receiving the placebo?
Very good. So let's look at the data. I want you all to look at the data for 30 seconds. Very important. Think through the data. Think through the data. Okay. So let's go back to the story. Let me quickly give out some quick marks because of understanding. Now, she was trying to pronounce this word and she was struggling to pronounce it. Who can pronounce the word for us? Who can pronounce the word that we are highlighting here? This one.
Placebo.
This word, my cursor is hovering around it. What word is that in red?
Yeah.
What word is that? Desmond is not ready. Who can pronounce the word for us? Yes, Jeblin.
Dyspnea.
Okay, that is wrong. That's none. S&M.
Dyspnea.
Okay, urea. That's wrong. Urea.
Dyspnea.
That's wrong. Loretta.
Dyspnea.
Again.
Dyspnea.
Very good. That's a word. So tell us why I said yours is good. If you don't tell us, you are wrong. Why is yours good?
You don't pronounce the P.
Very good. That's it. 2 months. Okay. Dyspnea. Dyspnea. Or dyspnea. Or dyspnea. Whatever it is, you don't pronounce the P. Okay. What is dyspnea? You can tell us. Based on the story, what is dyspnea? Let's try to get a context. What is dyspnea? Last rep, I hope you took note of the 2 marks. What is dyspnea? Pamela.
Prof, that's a shortness of breath.
Shortness of breath. Simple. Okay. Shortness of breath. So basically, dyspnea is a symptom of asthma. Okay. Now, what shows that we have to use a Mann-Whitney U test for this question? What shows that we have to use a Mann-Whitney U test for this question? What shows? Solomon.
We were told that the data is non-normally distributed because I said non-parametric.
Very good. Excellent. 2 marks. So the data, because it's non-normally distributed, it fits that. And also, it is an independent sample. Independent sample. And you see that from the result here. Okay. The number of episodes of shortness of breath for those that took the placebo. You can see that the first person who took the placebo had 7 episodes of shortness of breath. The first person who took the new drug had 3 episodes of shortness of breath. The second person who took the placebo had 5 episodes. And the second person who took the new drug had 6 episodes. And it goes on and on and on. Now, when you look at the last person who took the placebo, he had 12 episodes. But the last person who took the new drug had 1 episode. Question. Just from hindsight, would you say that the new drug was good or effective, or it was not effective? Who can tell us? From hindsight. Martha Dapa. And why?
I believe it's more effective. Looking at the number of episodes that occurred after taking the new drug.
Pardon?
I'm saying that I believe the new drug was effective. Looking at the number of
We are all looking at the
episodes.
number. You have to tell us the number that we are looking.
Okay, so as compared to placebo, the new drug gave the person 3 episodes, which is less than 7 episodes that those who took placebo took. And for the last one,
Why are you using the
person had
same thing I spoke about? You are copying me. You can use your
Okay,
own words.
so I can use the middle side. So
Why don't you speak in general terms?
So I'm saying that the new drug is more effective because it reduces the number of shortness of breath that the patient gets as compared to placebo.
That's all you should say. That's it. You shouldn't be picking on the individuals. You should speak in general or average term. Very good, 2 marks. So that's how it's supposed to be executed. Now, so guys, we are going to check whether, look at the sentence, is there a difference in the number of shortness of breath over the 1-week period between participants receiving the new drug as compared to those receiving the placebo? Now, if you check carefully, in the data set, which one comes first? Is it the new drug guy or the placebo guy? Which one appears first? Desmond. Which one? Which group appears first in the table?
The placebo.
The placebo. Placebo. So the placebo is coming first. So that is what you have to take note. So on the basis of this, I want somebody to tell us how you would have formulated the hypothesis. Now, if you are representing the median for the placebo, call it M subscript P for the placebo. If you are representing the median for the new drug, call it M subscript NP. Okay. Sorry, N subscript ND. ND. So, looking at the storyline, we will be able to formulate the null and the alternative hypothesis. Who can intelligibly do that? The null and the alternative hypothesis. From your heart, from your mind. Uriel. Uriel.
So the now hypothesis will be MP is equal to MND, and the alternative will be MP is not equal to MND.
Which word is guiding your thoughts?
Pardon?
Which word in the
Um,
story is guiding your thought?
is there a difference?
Very good. Is there a difference? Excellent. 2 marks. That is how you formulate the null and alternative hypothesis. And if you are here and you don't understand, raise your hand. We'll help you. If you are here, you don't understand, raise your hand. We help you. Fantastic. You'll get it. Okay. So normally, if you were taking a real life situation, one of the first things you got to do before or not to use the Mann-Whitney, one of the things to do is to determine whether the data is normally distributed. Now, how do you determine the distribution of the data? Well, if you do the distribution and it looks bell-shaped like this, it means that it's normally distributed. If it looks like that, it means it's skewed. Okay. If it looks like this, it means it's skewed. Okay. And if it is skewed, then you are going to use this Mann-Whitney U-test or the Wilcoxon-Rankin test. Now, you guys don't have the time to calculate, but one way you can do it is either you use kernel density plot, the one I just used, or you can use histogram. Okay. So let's look at histogram. This is a histogram of the data. We have plotted the frequencies of all of them, all of the data points. Looking at this, what can you say? Looking at a frequency histogram, would you say that this data is normally distributed or is not normally distributed? Yes. I'll ask you why. So think about the why. Yes, Jebley.
Okay, so it's not normally distributed because it's not bell-shaped, and it's also skewed a bit. The sides aren't even on both sides.
How do you know it's not normally distributed by looking at this? How do you know?
So look at the bars, the individual bars. They don't like collectively form a bell shape. So to be a bell shape, I think the middle one would have been higher than the opposite sides would have like more or less equally going down. But it seems it's uneven on this side. The right side, it seems that it goes up and then it goes down. The left side, it goes up, down, up, down. So it's not it's distributed in that order.
Excellent. 2 marks. That's how it's supposed to be. So now we can confirm that it's not normally distributed. So it makes sense to use the Mann-Whitney U-test. Okay. Now, how do you execute the text? Remember that the first thing you would have done is you would have calculated you would have formulated the hypothesis, which we have done. Okay. For those of you who are following, the hypothesis was formulated as H naught was M placebo equal to M new drug. Okay. And then the alternative was formulated by our dear lady as M placebo not equal to M new drug. So this is how the null and alternative, but of course, you have to understand what you've just formulated and say it in English, not using equal to and all of that. So the first one is saying that there is no difference in the number of episodes of shortness of breath. That's what the first one is saying, that there is no difference in the number of episodes of shortness of breath. And then the other one is saying that, come on, there's a difference. There's a difference. Now, if there's a difference, the difference can go either way. Either the number of episodes of shortness of breath between the placebo guys is higher or is lower than that of the new drug. Now, for the new drug to be effective, should it be higher or lower? For the new drug to be effective, in the alternative, should it be higher or lower? You got to be following me 100% to address this. And I'll ask you why. Loretta,
It should be lower.
which one should be lower?
The new drag should be lower
Why?
because we are checking how effective it is. So if it's been administered and it has reduced, then
What
we
has
know that
reduced?
the shortness of breath has reduced. Then we know that the new drag is effective.
But what?
Sorry?
But what?
I'm not sure I get
But
you.
what do we mean when you know that it's not effective? That's what I'm saying.
Oh, sorry. We know it's not effective if it is higher. If the numbers that are being recorded are higher, although the new drug has been administered.
Very good. Excellent. Too much. That's how you interpret this. So you got to understand, not just writing the hypothesis. In an exam, you writing the hypothesis and explaining the hypothesis is more important. Okay. Okay, so how do we execute? There are a few things you want to take note. When you look at the sample, how many are the sample sizes in each group? By the way, the sample sizes are represented by N1 and N2. The 1 is the placebo group. The 2 is the new drug group. How many are the sample size in each? And how many are the total sample size? You can tell us. How many are the sample size? And how many are the Lawrence?
The sample size for each is 5.
Very good. Very good. And there's no mark for that, but you've done very well. We all know you've done very well. Yes.
That's okay.
Your time will come. Won't take come. Your time will come. All right. So we are going to execute the process. Along the line, we shall have 2 commandments. So what we are going to do is we are going to now formulate this thing in such a way. You're going to have a table. And in the table, you will have the placebo column. Okay. And then you will have the new drug column. Then you will have the rank for the placebo column. Then you have the rank for the new drug column. That's what we are going to do. So you should be doing that as well. Okay. So you are going to write these numbers in ascending order. But when you are writing them in an ascending order, don't forget the group that they belong to. Okay. You're going to write them in an ascending order, but don't forget the group that they belong to. So let's start writing them. What is the first number we are going to write? In an ascending order, what will be the first number? Anybody?
1.
1. So this one we can all be saying together. And which group is it going to belong to?
New drug.
New drug. So you will write it here under the new drug, just 1. The second number.
2.
Which group?
New drug.
So you write it under new drug, 2. The next number.
3.
Which group?
New drug.
So you write it under the new drug. The next number.
4.
Which group?
Both new drug and
Both.
placebo.
So you will always say both. So you write it here, both, and then you write it here as well. Next number.
5.
Which group?
Placebo.
So you write it under placebo. The next one.
6.
Which group?
Both.
Placebo and new.
Yeah.
So you write it under both. The next one.
7.
Which group?
Placebo.
Placebo. Next one.
12.
Which group?
Placebo.
Placebo. Excellent. This is the first step. That's not the difficult part. So now you've organized your work and you're ready to rock and rumble. The next thing is to rank them, rank the numbers. Now, because you have put them already in an ascending order, it becomes easier to rank them. But there are some two rules of the ranking you need to understand. When you are ranking, you should always remember that the ranking goes in a form of number 1, first, number 2, second, number 3, third, number 4, fourth, number 5, fifth, number 6, sixth, number 7, seventh, number 8, eighth, number 9, ninth, number 10th. See the way my tongue is coming out? Th. So these are positions, but we are going to use 1, 2, 3 to be able to address them. But when there is a tie, okay, when there is a tie, you got to add the rank. Find the average of the rank, and then you are sorted. Now, this part is hard, so pay attention. I'm going to do one on the right here, so you can appreciate. Suppose you have group A.
Hello, sir. Please, I have a question.
Yes.
Okay, so I know we're writing the numbers in ascending order under placebo and drug, but I noticed that so why didn't we start maybe number 4 under placebo on the same level as new drug? Because that would be the first number under that one. Is there a reason why we
Is there a reason why that we didn't write the 4 at the top?
Yes, please.
You could have written it at the top. There's no problem. The only thing is that it helps you to know that we are on the same level. The 4 is appearing here.
Okay.
So that you see them together with your eye. But it's okay to be, doing it and pushing it all up under the placebo. Okay. So we have A and B here. The first number is 4. And then you have 5 here. Okay. Then you have 6. You have 6. You have 6. You have 6. Then you have 7. No. Let me take something. Then you have something like 12. And then 12. And then you have 13. You have 13. And then here you have 13. So we're going to do the ranking of this. And I've deliberately written them the way they are. If you can understand this, what we have already is easier. We're going to rank them. Okay. So let's assume that the rankings are going to be, let's say the rank of A is going to be here, and then the rank of B is going to be there. Now, I've already organized them in ascending order. So the first position will be for which number? Number 1 will be for which number? 4. Do you all agree with that?
Yes.
Okay. Yeah. So that will be this. Number 2 will be for which number?
5.
5.
5.
So this 5 will have number 2. Number 3, number 4, number 5, and number 6, they are all a tie, isn't it? Do you agree with that?
Yes.
So
Yes.
because they are all a tie, you're going to write number 3, because we are starting with 3. Pay attention here because this is tricky. So you're going to write 3 plus 4 plus 5 plus 6 divided by 4. You find the average. Don't forget where you ended. You ended at 6. So when you take 3 plus 4, that's 7. 7 plus 5, that is 12. 12 plus 6, that is 18. 18 divided by 4. Pamela.
Prof, I'm sorry. I think I may have
I
missed
told you
something.
some of you will get confused. I'm not starting.
No, I got disconnected a bit and I had to rejoin. But what I'm not sure about is I was following when we did the ranking under the placebo and the new drug. But this A and B, I'm not sure where those numbers are coming from.
Can somebody tell her where they are coming from? Quickly, or they are call back. So can somebody quickly tell her? Yes, Priscilla, tell her.
So, Pamela, we are trying to understand how to do the ranking for the question that we are we are answering for the placebo and new drug. So these are just random numbers and a sample question that can help us do the rank.
Okay, so these numbers under the A and B are random. They are not part of the question. We just made them up.
Yes, trying to
Precise.
and answer what we already have.
Okay, thank you. Prof, thank you.
All right. So the first number 4 will be ranked at rank 1. The second number 5 will be ranked as rank 2. But because there's a tie, whenever you are doing and there's a tie, what you do, and write this down, what you do with a tie is that you would take the average of the rank, not the numbers you are seeing, but you would take the average of the rank. Because like this number 6 would have been given a rank of 3. This number 6 would have been given a rank of 4. This number 6 would have been given a rank of 5. And this number 6 would have been given a rank of 6. But now, because they are all having a tie, we will take the average of the rank. Write this down. You take the average of the ranks, but not the numbers themselves. Not the average of the numbers, but the average of the ranks. So what will be the average of these ranks? I know some of you have calculated it already. What is the average?
4.5.
Good. Now that you know it's 4.5, you're going to give this guy on the left 4.5, this guy on the right 4.5. You are sharing that rank for all of them because they are tied. Then you give this one 4.5, and then you give this one 4.5. But you should never forget where you ended in the ranking. You ended at rank number what? 6. So in your continuation, you got to continue from rank 6. You get it? You got to continue from rank 6. So the next rank will be what? Kathy. What's it name?
It's good.
Priscilla.
Sorry, I was muted. 12 hours muted. 7.5.
Okay. She's already done it perfectly. The next rank will be rank 7 and rank 8 because they are all 12. They are all a tie. So it would have been 7 and rank 8. But because they are a tie, we take the average of 7 and 8, and that will be 7.5 each. So you're going to give this 12, 7.5, and this one 7.5. And the next rank will be what?
10.
No, the next rank. You give me the rank first before you find the average. The next
9.
9 plus 10.
10 plus 11.
So it'll be 9, 10, 11.
Yes.
Okay. So you will now take the average of 9, 10, 11. And the average of 9, 10, 11 is 10. So you're going to give 10, a rank of 10 to the 13 here, a rank of 10 to the 13 here, and a rank of 10 to the 13 here. That is how you do the ranking. Any question? Any question? Yes. Gabriel.
Yes, Doc, please, I have a question. So if they're going to be the same, so let's say you find the average, if we're going to repeat them for all the numbers, why don't we just use the average we're going to use, so the rank we're going to use for that number for all of them. So let's take 6. Instead of finding the average of 3, 4, 5, and 6, and then using 4.5 for all the sixes, why wouldn't you just use the rank of 3 and use it for all the sixes?
Oh, when you do the rank of 3 for all the 6, that is dangerous. That is dangerous because they are, you see, it's the ranking. The ranking is based on the total number. And you're going to see very soon that the total number of rank, at the end of the day, the final rank should be equal to the total number of observations. The final rank. When you count them, you are going to have the total. Okay. So as an example, if you take in your head, the final rank would have been what? It was 10, it was 9, 10, and 11, isn't it?
Yes.
Yes.
It was 9, 10, and 11. That was the final one. So when you count the sample, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. When you add them together, you should have 11. So at the end of the day, the rank must match. But if you give 3 here, and 3 here, and 3 here, and 3 here, you don't match it. And there's another rule that you're going to see, the first commandment. Okay, and that first commandment must tally. You're going to see that very soon. The first commandment says that, and we'll come back to that. I don't want to say it now. It says that the sum of the first rank and that of the second rank, when you sum them and you divide it by 2, it should be equal to the overall divided by 2. Let me just quickly give you this, then you write it down, okay, before we even get there. So this is a rule. This is the first commandment. The first commandment says that, this one, that when you take the sum of the ranks, okay, when you take the total rank, so in this case, when you can add all the ranks on the left side here, rank of A together, you have 1 plus 4.5 plus 4.5 plus 7.5 plus 10. When you add all of this together, okay, you get some total rank. And then you add all of this one together, you get a total rank. When you add the two total ranks together, it should be equal to the sample size plus the sample size plus 1 divided by 2. It should be equal here. And we'll verify. In fact, I can let you verify, but that's not my focus for this one was just to cut in. My focus, I'll be using this one to verify for you. So you can't just split the numbers. Otherwise, you cannot bypass the commandment, the two commandments. Okay, do you understand?
Yes, please. Thank you.
Okay. So now let's go up here. This one. So now that you understand this one here on the right side, I'm going to wipe it away and then we deal with the one here. Hey, let me see. Okay. I'm wiping this away. Okay. But that's okay. You get it now. So let's go back to our original now. In this our original, we are going to rank them. I think at this stage it's going to be easy. So the first rank will be what number? This one is going to be quick. The first one. Which group is that?
1. New drag.
New drag. Next.
2, new drag.
Next.
3.
3, new drag.
Next.
4.5 for both new drag and
next.
placebo.
6 for placebo.
6 for placebo.
Next.
7.5 for both.
Next.
9 for
9 for placebo.
Next.
10 for placebo.
Very good. So that's it. Now you see, I took you through an example, so you crushing it into pieces. Okay. Now, what you have to do is to find the total rank here and the total rank here. The total rank here, we'll call it R1, the rank of 1. And the total rank here, we'll call it R2, the rank of 2. What did you get?
Sir, please, I have a question. Please, I'm sorry I'm dragging us back. I think I went off the same time the lady who asked the question about these the numbers. And the explanation that was given was that we're putting random numbers. But from this example, I can see the numbers are not random. I think some calculation went into it.
Of course, some calculation went into it. Of course, your colleague students were actually calculating from their head because we've done an example on the right before.
So, sir, please, I want to know how this calculation was done.
That means that you didn't know how the calculation of the other one went.
No, because I went off at the same time after
Everybody is going to go
phone went
off
off.
and then come back and we have to repeat it. So my advice is that you got to go through the recording again. Because otherwise it means that anytime somebody goes off, I need to go and repeat it. And that cannot be established that way. You got to go through the recording and then be able to follow that. Otherwise we can't wrap up because we've got a lot of things to catch up. Okay, so I want you all to add up. Follow from here. Follow me from here. You don't have to switch off. Follow from here. And then if you don't get this, you can go and look at that later. What is the total for the rank 1?
37.
37. And what is the total for the rank 2?
18.
You see, you have to have a pen and a book writing these things down. It helps you to focus. Because when I wipe things away, then you are stuck if you are not writing. That's what the problem is. Okay. So now our rank 1 is 37, our rank 2 is 18. Then we come to the first commandment. The first commandment says that the sum of the first rank, okay, the R1 plus the R2 should be equal to, write it, should be equal to n into bracket n plus 1 divided by 2. Now, R1 is 37. R2 is 18. According to them, if we add them, it should be equal to what we're about to do as well. When you add them, what do you get?
55.
Okay, so let's put a 55 here. And then let's go to the other one. The sample size, the total sample size. What is the total sample size in this data?
10.
10. Then it says that take that 10, add 1 to it, making 11. Now multiply the 11 by the 10. 11 by 10 is what?
110.
110 divided by 2.
55.
55. So once you get the two matching, it means you are already on track going. It means that all that you've done in your ranking was correct. But that is not the ultimate, because you may still be wrong and still be correct until you double check the next one. So this is what we call the first commandment. Now, you know which one is rank 1. You know which one is rank 2. What is the next thing? The next is to calculate the U statistic for both. Now, the U statistic is given by the R1, that is the total of this, minus N1 into bracket N1 plus 1 divided by 2. And you do the same thing for the second one. So take the first rank, R1. That one is the one here. What is our R1?
37.
37. Okay, so you write 37 here. Minus N1. When you go to the placebo group, the total sample within the placebo group, how many were they?
5.
5. Then you have this 5 again plus 1. What is that? 6. 6 times a 5?
30.
30 divided by 2?
15.
So you do 15 and then try and find the answer. What is the answer? Miss Obi on my kasa on ye bin soda ni apon no so fan ho. Oh, fan ho it's on participating but on calculator no so be that. No.
Prof, 22.
Sorry?
22.
So you get 22. I want you all to calculate the U2 by yourself. The same thing you did with the U1. You're going to do similar one for the U2. Calculate by yourself. When you're done, raise your hand.
It's 3.
3.
3.
Okay. So who has been able to crack it so far? Who has the answer for you two? I'm looking for more hands. So it's the same old hands, the same participatory hands. I'm looking for Akosiata. Yes, Akosia.
Prof, you two is 3.
You two is 3. Very good. Very good. If you didn't know how to calculate U3, U2, we can show you that. We can show you that. So what led to the 3? What minus what? What minus 15?
18.
18 minus 15. So guys, you have U1 and you have U2. At this stage, there's one more commandment to check to be sure that you are on track. And what is that? The commandment says that, watch it, your U1 plus your U2 should be equal to your N1 times your N2. Write it down. If you check and they are equal, you are good to go. If you check and they are equal, you are good to go. Are they equal?
Yes, please.
They are both what?
25, 25.
Exactly. So this is 25 and this is 25. At this stage, you can call the invigilator and give him a whip because you are through. It means you are about to pass. Now, once you've done this, you are now ready to go to the final step. There are 2 different U statistics. Which one should you take? That's how you always work. There are 2 different U statistics. Which one should you take? And the answer is you always take the one with the smaller U. Therefore, your final U statistic should be equal to the one of the U's that is smaller. And which one is that? Which number?
You two.
U2.
Which number?
3.
3.
3.
Therefore, we can conclude that our U statistic is equal to 3. Remember, the second step in hypothesis testing is to find the test statistic. Well, that is what we just did. Now, your question you're about to ask me, as you do, is that why did we choose the U3? Is that it?
Sir, you are right, as if you knew.
As if I knew it.
You are right.
I've
You are right.
been doing this for years, so I know. Okay, let me show you something. But that's a smart thinking. Only smart people can actually think to ask that question. Okay. When you go back here, let me just take it back. All the things we are doing are here, by the way. Maybe I can. All the things we are doing are right here. So if you check this, where is it? So these were the values. You always take the smaller u. I know those were our, test statistics that we had. Why take the smaller u? Why take the smaller u? Now, what are we calculating? Is it ranking? Yes, ranking. Ranking. Now, when you are doing ranking, ordinarily, do you want a lower ranking or a higher ranking? Talk to me. Do you normally want a lower ranking or a higher ranking? What I'm saying is that, in terms of order of importance, if you are watching a football tournament, okay, and you want to know the best ranking, which is the best one? Is it a higher one or the lower one?
The lower one.
Lower one.
Exactly. That's what is applying here. And also it's because it's non-parametric. Now, when it is a parametric test, you want a higher statistic. But this is a non-parametric test, so you want a lower statistic. And that is the essence of selecting the lower value. As you do, are you with it?
Yes, I get it. But for the football ranking, now I've taken the higher one. But with the
are you sure?
parametric,
No.
yes, of course.
You mean first?
If I'm betting, I'll bet on the higher rank, the odds. So what people say, the higher
Well, it
one.
depends on what you understand by what I mean by higher rank. Right now.
But with the parametric, with the non-parametric, it gives me a better understanding. So I'll now accept the smaller or the lower one. I get it.
Okay. So which team was the best team in the World Cup?
Spain.
Were they the first or second or 22nd team?
The first.
Why are you taking the first? You say you don't want lower.
They are ranked number 1.
Yeah, but that is it. That is what we mean by, lower rank, lower value.
Okay.
It's the lower value.
Okay.
That is the best.
I get it. Thank you. Yeah, I see the angle.
It's the angle.
Okay, thank you.
On any angle. All right. So now that you have found the test statistic, you have to compare it with a critical value. Note it down. You got to compare the test statistic with a critical value. The critical value is always given by a certain formula. Generally, this is a critical value. Write it down. The critical value is basically U subscript alpha, comma, N1, comma, N2. In other words, the critical value is like a benchmark against which you compare your calculated analysis. Your calculated analysis is a U statistic that you found, the 3. Now you got to go find this. The alpha is called a level of significance. Alpha is a level of significance. Alpha is the expected error. Write it down, bro. Alpha is the expected error in any research analysis. Is a level of significance. Is the error you are expected to have. Yes, patience.
Please, is the alpha the one in the red ink or the one you have done like that's in the blue?
The blue. The blue.
Okay. The blue is your alpha. Okay.
Yeah. Because I've simplified the alpha that you've seen written here in red. I've simplified it. So the blue is the right alpha.
All right, sure.
Okay. So now so there are three major alphas. We have the 0.1%, 1%, and then 5%. Sometimes we add a 10%, but there are 3 major ones. Now, whenever the alpha is given to you in an exam or anywhere, you'll be told. But then when it is not given to you, the default alpha is always 5%. Note it down. The default alpha is always 5%. So we already know our N1 value. What is the N1? And what is the N2?
5.
So you have mu 0.05 is the alpha. N1 is 5, N2 is 5. Now, this is a critical value, so you have to check it from the table. The table is known as U table, Mann-Whitney U table. I also sent you that table. So I'm going to open the table here, then we all look at it. Okay, so this on your screen is the Mann-Whitney U table. I'm making it bigger. Let me clean this thing. Okay, so that you can see it well. Now watch that. The table has got two tail, and when you go down, it also has another one, which is one tail. So it has a two tail one, and it has a one tail one. Both of them are given to you. Which one should you take? Well, the one you take comes from the hypothesis that you formulated. I'm sure you all remember the hypothesis that Medell lady formulated. That hypothesis, do you remember that it was exactly what tail? Oh, for your information, whenever you are using equal to and not equal to, that is two tail. Whenever you are using less than or greater or equal to, or greater than and less or equal to, these four are always one tail. And then the first two are always two tail. So which one do you think we have been using all along?
Two tail.
Two tail.
Two tail. So when you get to the test, you will go nowhere to the one tail, but in this very example, you go to the two tail. Okay, so now we are in the two tail. Look at the two tail carefully. The alpha is provided here. And you will also notice that the N1 is provided at the top and the N2 is provided on the far left. Now, you remember that your value for the N1 is what number?
5.
You're going to look for the 5 at the top row. Then your value for the N2 is what number?
5.
You're going to look for that number on the far left row. They will meet at a junction. That junction will have a 1% and a 5% alpha. Choose the 5% alpha and type your answer privately to me. And let me see. Everybody is watching. Type your answer privately to me and let me see. Because I don't want people to copy people.
Oh.
Okay, so I can see the answers people have written to me is a clear indication that people understand. Everybody, the answers they are giving me, everybody is getting it correct. And I'm seeing everybody writing 2, 2, 2, 2, 2, 2, 2. Correct. That is the answer. So when you do that, the junction point between 5 and 5 is going to be here. And the 5% one is going to be 2. Therefore, our critical value is what? Is 2. So now we are ready to compare and conclude. So you now make a conclusion that, and here is a rule. The rule is that, yes, Pamela.
Okay, so Prof, I wanted to ask why we chose the 5% and not the 1%.
Can somebody tell her why we chose a 5% and not a 1%? Yes. Is it Laurentia? Lawrence.
Yeah, you explain when the alpha value is not given, you use the 5%. That's 0.05.
Sorry, can you repeat that?
When the alpha value is not given in the question, you use the
Hello?
5%. Can you hear me?
Okay, so it's always 5 and 1. So when the alpha value is not given you, use a 5%.
Yes.
Exactly. So in this question,
Thank you.
we were not
Thank you.
told
Thank you.
whether it is 1% or 5%. And because we are not told, that is why we are using this very 5%. Okay. The rule is that whenever the test statistic, that's a rule. Oh. So you got to note it down. Whenever the test statistic is less than the critical value, we reject the null hypothesis. Whenever the test statistic is less or equal to the critical value, we reject the test statistics. So you can see that here, that whenever the U statistic, the minimum U, is less than or equal to the critical value, reject the null hypothesis. So in our own, are we going to reject the null hypothesis or we are not going to reject the null hypothesis? You can tell us. Are we rejecting the null or we are not rejecting the null? Yakindampo. Savoie. Yes.
Hello. Hello.
It takes you forever to always click. It's like when you raise your hand, you should be ready to unmute.
Please, can I talk?
Can you talk?
Me pacha hi.
Continue.
Okay. Please, you are not going to reject it.
Why?
Because the text statistics is higher than the critical value.
Okay, what does that mean? In terms of conclusion, what will be your conclusion? If you are not rejecting the null hypothesis, what would that mean? Anybody? When you are not rejecting the null, do you know what the null was saying? The null was saying that there is no difference in the episodes of shortness of breath between those taking the placebo versus those taking the new drug. That's what the null said. There's no difference. There is no difference. Apu, there's no difference. That new drug didn't do anything. There's no difference. You are rejecting that. So what are you concluding? Priscilla.
You are accepting that there is a difference.
Good. So what it means is that you are accepting that a difference does exist. And in this process, if the difference exists, then you are saying that whatever difference is statistically significant. The difference didn't just happen by chance. It's significant. What difference are we talking about here? We are talking about the difference between the total rank. If you can remember, the total rank, one was, what was the difference? One was 20-something patients.
37 and 18.
37 and
Sorry,
80. That difference is big. It's a very, very big difference.
Sorry, Prof, but we just said we are not, but they now said there's no difference, and we said we are not rejecting. And then the rule says we should reject if, okay, got it.
You got it?
Yeah,
So
yeah,
in
yeah,
our
got
case,
it.
we are not rejecting the different. We are not rejecting the null hypothesis. That's what I want to say. And it's true, we are not rejecting. We are not rejecting the null hypothesis.
Right. So then in other words,
the drag is bogus. The new drag is bogus.
okay, got it.
So that new drag that the people claim that it can, cut down the number of episodes of shortness of, even though from hindsight, it looks like the drag was good, especially if you look at the first and the last people comparatively. The last person had, one episode, what do you call it? One episode, whereas this one had 12 episodes. So it looked like the new drug was good, but statistically, the new drug is not good. I know why. So we can't reject the null hypothesis because 3 is greater than that. We only reject when the null hypothesis, when the test statistic is lower. But in this case, the test statistic of 3 is higher than the critical value of 2. So we can't reject the null hypothesis. And that means that we have a statistically significant evidence at the 5% level, alpha, to prove that the 2 medians of the number of episodes of shortness of breath are equal. We have enough evidence to prove that the medians are coming from the same population. Another way of concluding this is that there is no difference in the medians. There is no difference in the median. In other words, that new drug didn't make any difference. That's what it means. Guys, this part here is always 8 months. So your conclusion should be juxtaposed to your understanding. The new drug is not that, good, or it didn't make any huge difference. In terms of effectiveness, you could even say that a new drug is not effective. Why is the results like this? Who can tell me? Why is it that from hindsight, it looked like the results were good, but all of a sudden, when we subjected it to statistical torture, the result is not good? Why? Why?
Because of the sample size.
What has it done?
It's small. It's not significant enough to determine that.
When is it significant enough to determine?
We are only doing 5 of each.
So what should it have been?
I don't know, maybe a bigger sample size.
Well, how do you define bigger and how do you define smaller? You are there, but you didn't think about the other questions.
Okay.
Yeah, next time.
There should be a way of, okay, so.
There should be a way of
determining the sample size. Yeah, I just don't know how. I'll find out.
I see it knows.
Statistically, a minimum of 30.
That's the correct answer. Statistically, a minimum of 30, at least 30 is big. By the way, I'm giving the two of you 2 marks each. There was a CAD and who?
Thank you, sir.
There was a CAD and thank you, sir.
Henry. Henry.
So this is an important question because I tweak it all the time in an exam. So the sample size in this case is too small. How can you just take 5 people and administer placebo to them? And then 5 people administer that. The more people you get, the more you're going to be able to ensure that this thing is working perfect. Very good. Ladies and gentlemen, at this stage, we are ready to demonstrate everything we have done in the software called R. I'm sure you have all downloaded and installed your R. Is that correct? Have you all downloaded and installed your R?
Yes, sir.
Yes,
If you have your R installed, please raise your hand and let me see. If you have your R installed and your R Studio, open your R Studio. If you know you can open your R Studio, raise your hand. Maybe
Hello,
sure.
Prof.
Yes.
Hello, Prof. I downloaded. Unfortunately, I use a laptop that is limiting me. It's an official laptop, so I tried and I had some limitation. The administrator wouldn't allow me. So unfortunately, I'm in the field. So when I get back home, I'll get another laptop to download it. That's the challenge I had. But
But I'm not interested in your story. I'm interested in those that have it, not those who don't have it.
Yeah, okay.
So if you have it, let's rock and roll. Show me your hand if you have it. And open it, because I'm also opening mine. Mine is something like this. I mean, this is the first time you are opening your R, so I'm going to demonstrate. I know that you've seen a bit of, something about this R. You've seen a bit of something. So that's fine, but okay, let's try to. I thought I had it, but apparently it's not here. Okay, so you have your R data set. By the way, when you open, let me see by hands those who have it. Eight people have their R Studio open. Now, I'll be asking you to show me your screen by sharing your screen. So if you don't have it open, don't raise your hand. If you don't have it open, don't deceive yourself by raising your hand, because I will ask you, share me your screen right now. And I don't want you to say, oh, I'm having it on my phone. You can't have R on the phone. And so I'm expecting some of you to reduce your hand because you don't have R installed on your phone right now to show me now. Okay. So those of you who have your hands up, keep it up. Now, some people are forcing to do it all of a sudden. Don't do it though. Don't do it, okay? So they are still forcing to do it again, raising the hand. Okuma.
Hello, Prof.
I say, oh boy, then, Papa.
Hello, Prof.
So,
hello, Prof.
Go ahead.
Yeah, I was just wondering because there are web-based version of the R. Could those of us who are having difficulty installing the app on the desktop,
Don't
use
use a
the
web-based version. This is a serious work you used.
Okay.
Why are you having challenges installing? There was a video I put there for you to learn how to install, isn't it?
No, it's not about the process. It's about the limitations.
Administrator issues.
Yeah,
This is
the
real.
limitations of the machine.
Yeah, it's administrator issue.
But
But you can't use
Google,
somebody's machine. You should use your machine.
yeah. So that's why I was asking. Google has R available on Colab, and anybody can easily access that. For together with Python.
I know.
So I was.
Go and use that. It's fine.
Thank you, sir.
Okay, so let's continue. When you open your R, the first thing you see on the top left here is a command window. So what we see on the far left here, okay, here is a command window. What you see here is a command window. What you see here is a console. The console is where the results are shown. And then on the bottom right here, you have a lot of things, but more particularly plots are there. Plots are there, and then packages are also there. So these are the key ones that you need for this purpose. There are several things you'll learn in the process. In fact, most of you will probably even use it for your long essay and things. Okay. Right. So, how do you execute? Execute. First thing you want to do is to load your data. That's the most important thing. Now, I think that most of you will have the part here that is empty, unlike mine, which has a lot of writings. You guys here have yours empty like this, isn't it? With only the cursor blinking at number 1. Is that also?
I don't have, I'm only seeing our version and some
Remember, you are
images.
supposed to open your R Studio and not your R. Some of you may have wrongly gone to double click on R and opened R instead of opening R Studio. Now, how do you open R Studio? At the bottom of your window, in the search, type R Studio. R Studio, and then R Studio will pop if you have installed the R Studio. R Studio. Okay. And then the R Studio will pop. Let me just show you. Okay. When you click here, you type R Studio. You see that the R Studio will pop. And that will tell you that you have installed R Studio. The lady was talking. Are you sure you've installed R Studio? If you have,
Yes, please. Yes, I
then
just found it. So I was
so
in
you were
R.
not
Now
opening the R
I'm
Studio, wasn't it? You're opening the R.
in the studio now.
Okay. So once you've opened the R Studio, you can move along with me. Now, lower your hands. Those of you who have installed it, lower your hands so that in case somebody has a question to ask, the person can ask. Okay. Now, you can enter your data point, actually. You can enter your data, or you can import it from Excel. Solomon, why is your hand up? You can import it. So, open a new Excel. Open a new Excel. Excel. So, I am trying to open a new Excel sheet. You to try and open a new Excel sheet. I just want us to type the data there, a new Excel. And your data set that we have been dealing with, this data set, you know, we had the data in the question like this. Okay. You see the way the data was? Come on. I'm going to label it vertical so that, so watch the way I'm doing it. Okay. I'm going to do it as type. So I'm going to type it here. At the first column, I'm using type, all small letters, always use all small letters. Then under the type placebo, 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 like I'm doing. I'm sure you cannot see my screen, do you?
Yes.
Then you can see that I can click here and drag it for the first 5. Okay. So that placebo becomes 5 times. Then the next time, type new drag, all one word, new drag, new drag, new drag. And remember that the new drag will follow. The placebo comes first, the new drag follows. That one too is 5. That one too is 5. Then on the right, you type episode. Episode. I think that in the R, I use a different thing. So let me see whether I can use the same thing that was in the R. Okay. So I use drag and then group. So here I use group. So instead of type, I use group. And then here I use drag. Drag. Okay. So what was the first number? Well, if you go back to the data set, I mean, normally in real life, you would have gotten your data set already and you would have brought it. So the first number is 7, 5, 6, 4, 12. So let's do that. 7, 5, 6, 4, 12. And then the next one was 3, 6, 4, 2, 1. 3, 6, 4, 2, 1. Okay, so this is your data set. Hey, my 3 is not showing. All right. I'm sure you've all typed your data, have you? Have you?
Yes, Doc.
Okay. So look at this command that you have here. You're going to type this command in your, if you have the slides, you can just copy and paste. Okay. So just go here. You see that I've typed WM. WM. Okay. Just copy this read.delem, or you can type it into your R. So when you go to your R studio, your first command, type what I'm typing here, WM equal to. Let's just make this equal to. WM equal to read.delem into bracket double apostrophe clipboard or apostrophe clipboard. Just do that. Just type into that command window. You see, what I've just done is that I've shown you the manual way of doing this thing, and I'm showing you the practical software way, because in real life, you deal with a bigger data. Okay. So now that you've finished, let's load the data. Go to your Excel, copy the entire data set. Click anywhere inside, do Control A to copy, Control A to highlight, Control C to copy. Or if you like, you can drag it and then copy all of them. This one, you've done it many times in your job place. Come to your R Studio. Don't wait for me to get to the final end before you say, hey, how did you do it? If you are doing what I'm doing and you don't get it, ask. Click anywhere in the number 1 and do Control down, Enter. That will load the data into your studio. How do you know? Look down in the console, down here. When you look down here in the console, you will see that the thing has written blue. And that means that the data has been loaded into R. Now, how did you get that? Well, you have to click inside the number 1. And the moment you click there and you do Control Enter, or instead of Control Enter, you can click Run here at the top. When you click Run, the thing will run and you see the results in blue. Who has been able to do that? Who sees the result in blue?
I don't even know where to input this.
You have one person. There's always one person. Ajokache. Onye easy pa, onye easy one. You are ready. Sadat. She's also ready. There are people and there are people. Okay?
Doc, please, I see the result in blue, but then I also see an error message underneath.
What does the error say?
It says error in file, two brackets, file RT, then colon X11. Model
No
cannot be
problem.
loaded.
What you have to do is go and copy your data. Maybe you didn't copy. You know how to copy data, right?
Yes.
So copy the data clearly and come and click the number 1 and run it again.
Okay.
Now, for those of you who have done it, if you want to be sure whether you've done the correct thing, okay, if you want to be sure that the thing is truly loaded, all you have to do is just highlight the WM and run it. Run only the WM. When I say run it, I mean on the top here, you see run. Then you click run. Just highlight only the WM and run it. You see the data showing down there now. You see the data now showing down there. And that means that the data is loaded. Okay. The next thing to do is you can do a box plot, a quick box plot of the data. A quick box plot. How do you do that? Just type the word box plot, box plot, box plot. And then you see the box plot popping, like mine is popping here. You click on it, box plot. Inside the box plot, write the name of the data. The name of the data is WM. Do a comma. Okay, WM. And then you type a color. The color, type COL. Okay, and then you see that equal to, type COL equal to, and then you can type color green. I am doing double apostrophe, and then type green. See, the moment you type green, the color green will come. Some of you should use red and all that. We are about to do a box plot of the data. You click enter. While the cursor is there, you click enter. Okay, so this one says there's a mistake. Let's see. Okay. For this thing to work, normally you have to attach the data. So you have to attach the data, but let me just quickly get a deep dive analytics of why. Okay. So in order to be sure that you're on track, let me rerun the data again, and you should always double check. Okay, so this one is still looking good. What did the error say? Let me see the error. Okay, I may have swapped it. But if you run it, you will also get a similar error. So if you're getting a similar error, let me know. Okay, dokie. Oh. We just want to show a quick video, a quick color work. Okay. So instead of this, let's just rather do this. Instead of this box plot, let's just do this. Please watch what I've done. Box plot WM $drag. Let's do that. And that should show this. Box plot WM $drag, rather. And that should show you the box plot. It tells you that a number is an outlier. Which number do you think is the outlier here? Out of the data point, do you know that one of them is an outlier? Which number is that?
12.
Pardon?
12. 12.
12, exactly. 12 is an outlier. 12 is a beautiful outlier. In fact, there's another code that you can actually do, this one, okay, which will give you some other colors for both of them. Now, this code is hard one. This one gives you both the new drug and the placebo. Now, what I'm doing is I'm sending this one to your page, just so that for those of you who want to actually do it. I've just sent it to your page. You can just put it in your this thing, and then you can see the result. But then the most important thing is that now just looking at this, you can see that just on average, the box plots, the line in the middle shows the median, by the way. The black line in the middle, the black horizontal line is the median. Okay, so you can see that the placebo has a higher median. Okay, the placebo has a higher median than that of the new drug. You can see that clearly. And which one is carrying the outlier? Is it the new drug or the placebo?
The placebo.
Yeah, the placebo. The placebo is having the new drug, the outlier. You know. So on all of them put together, you get this first graph. Okay. But when you separate them with this command, you get to clearly see where the outlier is coming from. Okay. Our interest is to run the Wilcoxon. Please note, we are doing the Mann-Whitney U test, but it's the same as the Wilcoxon rank sum test. So let's look at a command. This is the most important one of today. So type this. You also have it in your code, in your slide. Wilcox.test into bracket drag. And then you bring your tilde sign. This tilde sign is assigned directly below the escape key. Then you type group. Now you want to show the confidence interval and you want to indicate whether this is a paired t-test, a paired test. Paired here means dependent, but ours is not dependent. Ours is independent. That's why we are using Mann-Whitney, if you could remember the table I gave you. So the paired, we are writing false. And the name of the data is called WM. So this will compute the Mann-Whitney test for you. Are you ready to run it? If you are ready, you click run at the top while the cursor is blinking in that number. When you click run, this is what you get. Okay, mine says there's an error. Let me see. Mine says there's an error. Let's see yours, whether there's any error. I mean, you can check yours. Some of you might not get an error. But let me see what the error is. Okay, so the formula does not accept paired argument. You know, so it's best to use. Okay, let me edit it. So you have Wilcox.test, then you have drag tilde group, and then instead of the confidence interval, let me just remove the entire confidence interval. Okay. Then you have, you don't need to write paired false. Just leave it as it is. Remove the paired false. Okay, and run it. Well, we still have an error here. Let me check. Confidence. Okay. Confidence through data. But everything is correct. Okay, let me just remove this one. Group data Wilcox dot. Cannot compute. Oh, the results has even come. But let me undo this and go and see. The results have come. Just there are some slight warnings, but don't worry about those ones. This is the main result. Okay. Do you all have your results like I do? So the most important thing is, do you see here that W is 3? Look here. Do you see that W is 3? Hello? Is anybody here? And I'm mobile.
Yes, please, we are here.
So you can see, I mean, you have all the code in your slide. So you can see that W is 3, and that was the same value we had. Okay. It tells you that the Wilcoxon rank sum test with continuity. And then the most important thing I'm interested in is the p-value. Okay. Now pay attention here. When the p-value is less than 5%, we reject the null hypothesis. And remember that in the null hypothesis, when the p-value is less than 5%, we reject the null hypothesis. The null hypothesis says that there is no difference. The null hypothesis says there is a difference. Okay. The difference is 0. The difference is 0. Now, in our case, in the one we did we reject the null or we didn't reject the null? Did we reject or we didn't reject?
We rejected the null.
We rejected the null.
Yes.
No. We didn't reject.
How? No, yeah.
No,
We didn't reject.
No, we didn't reject it.
The
Exactly.
placebo example.
We didn't reject.
Exactly. Well, okay. We didn't reject. What does that mean? If we didn't reject, what does that mean? Simple terms. Is there a difference or there is no difference?
There is no difference.
There's
There is no
no difference.
significant
There's no difference. So that's the same thing here. Okay. So you can see that here. Now, normally, sometimes it will give you the bigger value, which is a 22. Sometimes it will give you the smaller one. It doesn't matter. But we had the smaller value, the actual Wilcoxon value, which is 3. And you can see that we reject the null hypothesis when the p-value is less than 5%. Take note. We reject the null hypothesis when the p-value is less than 5%. But in this case, we can't reject the null hypothesis because the p-value is above 5%. Do you realize that the p-value is approximately 5.9%? Do you see that? Check it when you round it up. What I've highlighted. The p-value is approximately 5.9%, which means we cannot reject the null hypothesis. Okay. And what does that mean? If you cannot reject the null hypothesis, what it simply means is that the two samples are more or less the same. In other words, the new drug didn't make any big difference. Ibrahim, your hand is up. Ibrahim, your hand is up.
Yeah, Prof. So I don't know if the p-value we should get should be the same because they are all using the same data set.
Sometimes you are using the same data set, but you may have typed the different numbers.
Okay.
So you may have to go and check whether your numbers here agree with mine. Count your numbers. Look at your Excel and tell me your numbers. Is it 7564?
Yeah, 7564212 36421.
Okay. And then you had a different p-value.
Yeah, so the thing is they are close, but they are not exact. So I just don't know.
Well, you need to just check. What was your command? Read your last command.
Wilcox.tests, and then I have drag group, and then confidence interval is true, and then data is equal to WM.
Okay. And your data set, your group comes first and your drag comes second.
Yes, my group comes first and then my drag comes second.
But you're able to share your screen, aren't you?
Yes, let me try. Oh, I can't.
Okay, hold on.
Yeah.
Okay, I've made it possible for multiple.
You cannot share what other.
Multiple sharing. So you try. Otherwise, just raise your hand and let me show.
Okay, it's come now. So let me see.
Don't worry, I've made your co-host.
Okay. I don't know if you can see my screen.
Yeah, you show your data, your result. Go to where your result is.
Okay, so here. And
Right.
then I have my results here. So my W is equal to 3, but then my p-value is 0.06349.
Go to the number 1 and run WM. Highlight WM alone and run it. Let me see.
Okay.
Okay, hold on. Yeah, you're on track. Okay. Right, now go up. Let me see the final result. The difference even in your location is slightly different.
Yeah.
Okay, let me see your confidence interval. -9.
Yes,
And
-9 and 0. Yeah.
Yeah, there's an approximation. That's all I can say.
Okay, all right. Okay.
Yes, there's an approximation.
Okay, sure. Thank you.
Maybe you are using the latest version. I'm using an older version too. But there's an approximation, so that's okay.
Okay, all right, cool. Thanks.
Right. So, guys, the most important thing is to be able to do what your colleague has done. I mean, the fact that he's been able to run this thing as he has been able to run, that's all. The ability to run it, this is it. This is a starting point. Okay. Now, let me take you back to here, to the slides here. This is something you should practice as an assignment. This time, you can see that you have UG and KNUST salaries in thousands of cedis. And you can see that the sample size are different. UG numbers are different from KNUST numbers. Work it out. Work it out by manual and work it out by the R software. Now, do you see that there are ties here? Which ties do you see? Which numerical ties? Anybody mention? Which numerical ties?
29.
29. What else?
32.
Good. So there are some ties that you encounter and you know how to deal with it. That's the question. Okay. Next time we meet, we are going to start ANOVA and start that of correlation and regression. If you have a question at this stage, please ask. If not, that brings us to the end of the entire Kabudo.